Hello everyone, welcome back. This is the third part of the series that we are going through. So we started with two black boxes, which was very unknown to us. We as a user used mobile to send some request, and we got the response. All we know is there is a server sitting somewhere, and it is processing my request and sending me the response. So in this journey, we understood how my URL has been converted into the IP address and that the IP address was further used in all the communications. And next thing we did was we jumped to the server side. We took out the database from our black box and we understood what database scaling is. How do we scale vertically? How do we scale horizontally? And next thing we will see is how we scale the backend servers. Now, backend servers are the servers which run your service codes. So, the service codes means the code that you have written in the backend language and you are running it on some machine in the backend. So, in this session, we will talk about how we will make our system highly scalable. So, the last thing we talked was our system is becoming popular. Now, it is not serving just one user, it has started serving multiple users. So, this kind of setup, which looks local system setup, will not work if you want to commercialize your system or if you want to serve more than certain users because there will be lots of single point of failures. You cannot keep just one backend server which runs your code and processes your request. You will have to do some sort of replication of your backend server. So let's talk more about how you will scale your backend server to serve more requests because your website has become popular. Now you are honoring more than 1000 transactions per second. And similarly, you have scaled your database, which is now executing more than 1000 transactions per second. But your backend has not scaled yet. Your backend is still a single point of failure. So, similar concept you will apply over here. So, the very first thing people do is they think of scaling it vertically. They think of we will also do the same because we are taking the naive approach, then we are going to the correct solution. So the naive approach would be you make your the same system more powerful by adding resources to your existing server by making a more powerful CPU. But still it is a single point of failure. So what you do is you introduce you get introduced to the horizontal scaling. What horizontal scaling is, you do some replication. You create multiple backend servers. So this is replication. Your same code is running on multiple machines and all your request is distributed to these servers. So first thing comes to your mind is how does uh, how does backend server know which request to how do you distribute the load? Because lots of transactions are coming. You have scaled your server horizontally, but next thing you have to understand is how these requests are distributed throughout your servers evenly. By evenly, what I mean is your let's say you are getting 1000 transactions in a second. So you should have a mechanism to distribute your load, that 1,000 request, evenly to all the backend servers available. So for sake of explanation, let's say we have four backend servers. All are running the same code and all are in a replicated state. So you have to have a mechanism so that your 1,000 requests should be broken into 250, 250 each, so that all your backend servers honor that. To achieve that, we get introduced to one of the concept called load balancer. What load balancer does is it takes all the requests, it has information about all the servers that is running in the backend, and it evenly distributes the request to each of the server. Load balancer does not only do this, it keeps the track of your uh, number of backend servers also. It gets the heartbeat from your each server. Each server, what each server does is they say that they are alive and they are ready to take request. So load balancer knows this information, and the request that is coming from the clients reaches to the load balancer first, and load balancer then distributes that into the servers that is available in the backend. I have improved the diagram. I have included a load balancer, and which is accepting requests from all the user from the outer world. In this case, we are the users. We are sending the request. It is going to a load balancer, and that load balancer is having some algorithm which again selects which server to send the request to. These algorithms can be either round robin, smart balancing, or consistent hashing. So uh, the load balancer over here is introduced when you start scaling your system. By scaling, I mean is when you introduce replication, and it not only distributes the load, it also keeps a track of the load. So let's say in the evening, your website is more uh, traffic prone, which means that there are lots of requests coming in the evening. That generally does not come in the first half of the day. So for first half of the day, you would not spend money on multiple servers. So in that case, you will write one logic saying that if my traffic is less than 800 TPS, I only need two servers to handle the traffic. But if my traffic approaches 1000 TPS, introduce one more server or two more servers, whatever is the logic that you have introduced. So load balancer keeps the track of that also. So in the evening, it will scale your server and it will scale up. Then in the morning it will again scale down. So that's another uses of load balancer. So now load balancer can be a hardware or a software component. So if you get introduced to the cloud technologies, you will see there are lots of inbuilt load balancers, and those load balancers can be those load balancers are handled by the cloud provider, and you can use those load balancers and write your uh, logic, and they will act as if you have uh, written it. So they let's not get into that. We will discuss more about cloud-based load balancers later. But for now, let's come back to the topic where we were discussing that we have scaled our system, we have introduced the load balancer, and load balancer distributes the load evenly as well as it handles the scale up and scale down of the servers. Also, we saw that there is some algorithm written on the load balancer on the basis of which it distributes the load. The very simple one is the round robin, where first request goes to the first one, second to the second one, third to the third one. Then again in the round robin fashion, it will go fourth to the first one, similarly. And to make it more smart, uh, there is something called hashing technique, and which is kind of smart load balancing, where app servers keep sending their status to the load balancers. Load balancer constantly monitors and assigns the load. So let's say one of the requests where server takes a lot of time, and in round robin fashion, let's say we were using round robin fashion, and my server one was still occupied with some of the load. But according to round robin, my first server's term came. So load balancer will keep on bombarding to server 1, and server 1 will be overwhelmed and it might crash. So round robin is not a very good approach. That's why smart load balancing gets introduced, where servers send the status, where whether the server is available to take the request, what is the capacity it is currently running on. So let's say you have written a logic saying that if it is at 50% capacity, it can still accept the request. But if the server reaches to 80% of the capacity, it should not accept new requests. Rather, load balancer should decide which next server should the request go to. And in continuation, load balancer can again decide that, let's say all my servers are occupied, and I have a logic saying that all my servers are occupied at 80% load. Then load balancer will introduce on one new server to accept the new request. So by doing this, you make your system more robust. You make your system uh, more available, and by the same time, you also reduce the latency. By reducing latency, I mean is you are making your system so available and quick that your request processing does not take much time. If request processing does not take much time, so which means that latency is low and your system is highly a high processing system. So remember, we started with one user, and then we understood the DNS, then we scaled our database, then we scaled our server, we introduced load balancer, and this is how my simple diagram, which we started earlier, looks like now. So that is all I wanted to discuss in this video. In next video we will dig more about uh, how to uh, how to reduce the number of calls to the database. So at the moment you are processing all the requests to the servers, and servers are sending all the requests to the database. Now database is processing around 1000 transactions per second, but going forward it can be costly. So how we can improve our system to reduce the number of calls on the database, we will discuss in the next session. Thank you so much for watching.